Hello, everyone. Good afternoon, dear authors and invited guests. Welcome to Technical Session 11C. I am Pranjal Bange, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communications Technology for Sustainable Development ICT4SD 2026 in Goa, India. The 11th edition of the conference is being organized in a hybrid mode. The physical event was held the day before yesterday, 9 July 2026, in Goa, India, and the virtual event is being held through Zoom from 9 to 11 July 2026. I hope you'll enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for question and answers. In 8 minutes, I'll raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. Now, if you have any queries or updates, you can write it to me or to my co host in the chat box. Before we start the session, I'd like to introduce you all to the chair of this session, Dr. Bhagwan Dinkar Thorat. He is an assistant professor in the Artificial Intelligence and Data Science Department at Vishwakarma Institute of Technology, Pune, India. He holds a total over 17 years of extensive academic and research experience. He specializes in machine learning and deep learning with research contributions that also extend to areas such as cybersecurity. Good afternoon, sir. I'd like you to deliver a few opening remarks.
Okay, good afternoon, ma'am, and good afternoon, all of you. Uh, I'm honored to serve as a session chair for this session. And today's presentation represent valuable research contributions, and I'm confident that they will help to meaningful discussion and knowledge sharing. So I request all presenters and researchers to adhere to the allotted presentation within time, so that every author get an equal opportunity to present their work. Okay. And I would like to thank the conference organizer GR Foundation, and our session moderator, Ms. Pranjal Bange. Thank you all of you, and it's over to ma'am. So we'll start the sessions. Thank you all of you.
Thank you so much, sir, for your words. Now we'll be officially starting with the session. I'd like to invite Kushal Gupta to present his paper on a hybrid deep learning approach for grievance classification in digital governance systems. You may start with your presentation.
Good afternoon, ma'am. Is my screen is visible?
Yes, sir, your screen is visible.
So, good afternoon, respected chairpersons, distinguished panel members, and everyone present here. I am Kushal Gupta from School of Computer Science, UBS, Dehradun. Today, I am going to present our research work titled "A Hybrid Deep Learning Approach for Grievance Classification in Digital Governance System." This work focuses on improving automated grievance classification using deep learning techniques for both text and images. So this is our presentation outline. Every day, government portals such as CBgrams receive the thousands of complaints from citizens. These complaints are generally related to electricity, roads, sanitation, and water supply. However, most existing systems still depends on manual review or simple keyword matching. Such approaches are time consuming and often fail when complaints are ambiguous or involve multiple departments. Therefore, there is a need for an intelligent system that can automatically understand complaints and classify them correctly. So, we study existing approaches for grievance classification. Initially, researchers used traditional machine learning algorithms such as naive Bayes, support vector machines, and decision trees with TF-IDF features. Later, deep learning models such as CNN, RNN, LSTMs, GRU, and BERT significantly improved performance. Although BERT achieves high accuracy, it requires substantial computational resource and is difficult to deploy in real-time government system. Therefore, we selected GRU because it offers a good balance between computational efficiency and classification performance. So, during our literature survey, we identified four major gaps. First, there is a lack of publicly available real-world grievance datasets. Second, there are there are no standardized benchmark datasets. Third, most deployed system still depends on manual routing rather than AI. And previous research generally evaluates either text models or image models independently. Our work addresses these gaps by comparing both modalities using a hybrid framework. So our proposed framework consists of two independent deep learning models. For textual complaints, we use GRU network, which effectively captures sequential context while remaining computationally efficient. For image complaints, we use CNN combined with inception v3 and channel attention. The channel attention mechanism helps the model focus on the most informative regions of an image instead of processing all regions equally. The framework classifies grievance into four categories: electricity, road and infrastructure, sanitation, water supply. Our main contribution include developing a hybrid data set, designing an efficient GRE model, and improving image classification using channel attention. We prepare both text and image dataset. The text dataset contains 2,961 complaints, including 500 hard negative samples. These hard negative samples are intentionally designed to represent ambiguous and cross-domain complaints. For image classification, we collected about 15,000 images from Google Open Images, Flickr, municipal portals, and our own field photographs. Importantly, the 415 field images were kept completely separate during training and used only for final evaluation. For text classification, the complaint is first tokenized and converted into word embeddings. It then passes through two stacked GRU layers followed by fully connected layers before producing the final classification. GRU is selected because it effectively handles sequential dependencies while reducing computational complexity compared to LSTM. For image classification, we use Inception v3 as the backbone network. We integrate channel attention modules that enables the model to emphasize important visual features, such as potholes, water leakage, or damaged electrical poles. Both models were trained using the ADAM optimizer with a learning rate of 0.001. We used batch size of 32, categorical cross entropy loss, early stopping, and learning rate reduction to improve convergence and avoid overfitting. Our CNN with inception and channel attention achieved 97.62 accuracy with an AUC of 0.98. Water supply achieved the highest performance because pipeline leakage and water accumulation have very distinctive visual patterns. The GRU model achieved 93% test accuracy with macro AUC of 0.99. Electricity and sanitation achieved the highest score because they contain more distinctive vocabulary. Both models complement each other. The GRU model is lightweight and suitable for real-time complaint routing. The CNN model acts as an additional verification layer whenever a citizen uploads an image. Together, they provide a practical multimodal solution for digital governance system. To conclude, we proposed a hybrid deep learning framework for automated grievance classification. We introduced a challenging hybrid dataset contains hard negative complaints. The GRU achieved 93% accuracy, while the CNN with channel attention achieved 97.62% accuracy. Overall, the proposed framework can significantly improve the efficiency of government grievance management system. So these are some major references, and all references are in paper. Thank you. And if there is any question, I'm ready to answer.
Okay, Kushal, let me know. So, how to pre-process your data? Hello,
Yes, sir.
am I audible?
Yes, sir. So for the tax data, we converted all complaints to lowercase, removed special and non-alphanumeric characters, standardized white spaces, and tokenized the text. And using Keras tokenizer, like with a vocabulary size of 8,000, we also used out of vocabulary token for unseen words, and each complaint was padded for a fixed sequence length of 60 tokens. Or so for image data, we resized all images to uniform input size, normalized the pixel values, and applied basic data augmentation during training to improve generalization.
Okay, and which techniques for your images?
So we have used CBAM with channel attention with Inception V3.
Okay, okay, thank you, Kushal.
Thank you, sir.
Thank you, Kushal, for such a wonderful presentation.
Thank you, ma'am.
Now then, we'll be moving forward. I'd like to invite Kavin Prasant to present his paper on a machine learning, sorry, to present his paper on a machine learning based ICT framework for predicting carbon emissions, evidence from cross country energy and sustainability indicators. You may start with your presentation. Seems that Kavin is not present as of now.
Uh,
Then we'll be.
will you give me opportunity to present my paper, if you don't mind? I'm fifth guy in the row.
You're with Kavin Prasant, sir?
No. My name is Welcome Raju. Fifth person in the row. Fifth paper today in the session.
Yes, sir.
If
So
you,
you'll be presenting according to the order, sir.
yeah, okay. Welcome
Yes.
Raju.
Yes,
Shall
sir,
I?
you are in the schedule.
Shall I present?
So we'll call up your name when it's your turn.
Okay,
If
okay.
it's yeah. Thank you so much. Then now we'll be moving forward to the next candidate, Dialokant Singh, to present his paper on a note on model for three-parameter weighable distributed items with generalized demand under shortages.
Good afternoon to all of you.
Good afternoon, sir.
Good afternoon.
I am Dr. Tralona Singh. PPT visible?
Yes, sir, your PPT is visible.
Thank you. I am presenting my topic, a note on model for three-parameter weighable distributions, distributed items with generalized demand under shortages. Outline, introduction, related works, mathematical model, numerical examples, conclusion, hope for the future research, references. Introduction. Inventory management plays a crucial role in minimizing cost and ensuring the efficient availability of product in supply chain. Traditional UQ models have been progressively extended to incorporate realistic factors such as deterioration, time-dependent demand, shortages, and partial backlogging. This study develops an EOQ inventory model, economic order quantity model with time-dependent linear deterioration, quadratic demand pattern, partial backlogging during shortages. Our proposed model, which is suitable for items with changing demand over time, so that is valid for fashion items, cosmetics, seasonal goods, electronics, and automobiles. Our objective is to minimize the cost and maximize the profit. Related works. So, in this paper, we have incorporated quadratic demand models, um, variable distribution deteriorations, partial backlogging, special type of shortages, research gap. Most previous studies considered only for two realistic inventory factors at a time. Limited research integrates quadratic demand, variable distribution, and partial backlogging shortages in a single EOQ model. Therefore, there is a need for a comprehensive inventory model suitable for products with the changing demand and time-dependent deteriorations. So, mathematical model that includes notations, assumptions. Notations, first we have taken variable distribution deteriorated items, then quadratic demand, then various cost, ordering cost, holding cost, shortages cost, opportunity cost, and the basic variables or decision variables TD, TB, and capital T. Capital T denotes cycle length, and I1T inventory level within interval 0 to TD, I2T inventory level within interval TD to TB, and I3T within interval TB to T, and Imax nothing but maximum inventory level. Fundamental assumptions. In this model, we have taken only one type of items. These items of proposed inventory model follow a three-parameter variable distribution deterioration. Demand pattern is generalized demand, that is quadratic function of time. Shortages allowed, which is partial backlogged. Neither replacement or repairing for deteriorating items allowed during the running of system. Time horizon is infinite, and system cost is obtained. That is a quotient of addition of all different costs to the cycle length of the system. Then our graphical model. Initially, I max unit of item is assumed to available in our stock. The stock level diminishes, reduces due to the quadratic demand pattern, proposed demand pattern during the interval 0 to TD. Later, with respect to varying deterioration and quadratic demand function, it falls to 0 in the period TD to TB. Thereafter, deterioration rate, demand rate in the shortages interval TB to T, which is partial backlogging function of time. Therefore, taking this account, our differential equation in the interval 0 to TD becomes dI1T dt minus capital DT, which is nothing but demand pattern, quadratic demand pattern. Second differential equation dI2T dt plus theta T I2T minus dt, interval TD to TB. Solving for demand, as these differential equations are linear differential equations, we have to get integrating factor. Using integrating factor, we get solutions from first interval I1T, second interval I2T, then maximum stock level is obtained by putting boundary condition I10, that is IM, in the equation 3. Then we get I10. Then shortages case in the interval TB to T, third differential equation dit by dt minus demand pattern dt plus bt, backlogging pattern, where bt is 1 by 1 plus delta. Delta nothing but backlogging function, and our demand function is boundary conditions I3 TB 0, I3 capital T, that is minus b. Solving last equation, equation number 6, we get I3T, that is nothing but inventory level in the shortage period, maximum backlogged shortage, that is obtained from the boundary condition I3T, that is minus b. Therefore, order quantity is obtained sum of Imax plus IB. Then cost components, we have to evaluate cost components. First cost component, that is ordering cost, which is constant always C0. Then holding cost, which is computed unit holding cost capital small h, interval 0 to TD I1T, then interval TD to TB I2T. Simplifying these integrations, solving, we get holding cost, then deterioration cost, another cost component, unit shortage cost, that is CD, I2 TD minus interval TD to TB DT. Then shortages cost, which is obtained from the formula CS TB to T minus I3T dt. Then last component, cost component, opportunity cost. Then average system cost, average total cost, which is 1 by T, 1 by cycle length of total cost, sum of all cost, ordering cost, holding cost, deterioration cost, and the cost of opportunity. Then how to optimize this equation? So that is nothing but one parameter we have to optimize with respect to TB and T. The condition for optimizing cost function satisfying initial conditions, putting first derivative 0, another with respect to T, first derivative 0, provided they satisfy sufficient conditions. That is nothing but a second order Hessian matrix. So solving first differential equation, getting equation number 16, then solving second equation del Tt Tc Tb 2T by del T0, getting equation number 17, then putting in algorithm, getting our required parameters, required decision variables, TB star and T star, substituting in total cost, we get optimal total cost and optimal cycle length. Appendix A, B, C is nothing but calculation of Hessian matrix, provided all Hessian matrix are positives. Now numerical examples. So getting all system parameters, putting the values, at last we get order cycle, optimal order cycle 0.986060, and shortage time, that is TB star 0.919193. Putting in equation 15, we get total cost $50646.465 and maximize cost stock level, that is 830.566. Similarly, taking another numerical example, validating our theoretical model, we get shortage period PV star 0.923309 and a total cycle length 0.910059. Substituting these to get total cost, putting in equation 15, total cost is TC, TV star, T star, that is $505.759, and ordering items, that is 833.850. Then we get sensitivity analysis, taking example 1, putting
I'm
one
so
parameter
sorry to
fixed.
interrupt, sir, but I'd request you to conclude your presentation.
So getting numerical results and putting in sensitivity analysis, we get all validated of parameters. Then conclusions, developed EOQ model with the 3 parameter variable deterioration, quadratic demand and partial backlog shortage. The model captures both increase and decreasing demand trends, making it suitable for products with changing market demand. Determine the optimal cycle length, ordering quantity, shortage point, and minimum total inventory cost. Scope for future research, demand pattern may be generalized for time dependent demand, stock and price dependent demand, also in probabilistic or fuzzy surroundings, fuzzy parameters. The model may be generalized, allowing like inflation, quantity, discount, and other parameters. Our proposed work can be further extended by incorporating 1 or 2 level trade credit or grace period. So, taking these reference, we conclude. Thank you for
Thank you so much, sir, for your presentation. Now, I'd like to ask the session chair, sir, if you have any questions for him.
Yeah. Uh, Thank you, Dr. Tarluknath. So, just one question. So, why you selected three parameters, okay, instead of two parameters in available distribution? Am I audible?
Yes, sir, you're audible.
Okay, no issue, ma'am. We'll continue another session. Thank you.
Yes, sir. Then now we'll be moving forward. Just a minute. I would like to invite Satyam Prakash Srivastav to present his paper on AI-powered exposure in framing consumer loyalty towards on-demand delivery. Sir, you may start your presentation.
Uh, Very good afternoon. Am I audible, ma'am?
Yes, sir, you're audible.
Thank you so much. So shall I start?
Yes, sir, you can start.
Just a second. All right. Let me share my screen. Yeah. Is this legible, ma'am?
Yes, your screen is visible.
Oh, okay. Thank you so much. So, very good afternoon to one and all. My research topic is AI powered exposure in framing consumer loyalty towards on demand delivery. And my paper ID is 727, right? So, here I would like to discuss things today. Will be liking to present my things which will be based upon these content area. We'll start with the introductory, then moving forward towards the problem statement, followed by literature review, the objectives, the framework that is shown based upon the research results, and the methodology that has been adopted. Apart from it, the variables, the test, cronbach alpha, followed by the testing of the model has been done, and it will end up with some limitations and conclusion. So we all know that we are living into digital era, and time has come when customers have a lot of expectations from online delivery platforms. And more on, if you talk about the expectations, time has come when things are changing rapidly with due course of time. We can see that there has been a paradigm shift in recent past many years, and the data says that in the last few many years people have shifted towards their inclination of purchasing things, consumable items, through online delivery, which are working very fast these days. And if you talk about not only fast, they are ultra fast. And we know that there are certain big name and fame. There are big companies, there are big organizations that are providing us that support consistently, almost 24 into 7. So, in this digital era, consumer expectations of convenience, speed, and seamless service have grown dramatically. If you talk about the online delivery, we can see we have got the retail platforms that are promising with the commitment of providing the ultra fast delivery, uh, no matter whether it is related with any kind of personal care or groceries item, right? That if you talk about the companies, there are the competitors, the e-commerce platforms like Blinkit, Zepto, followed by Swiggy, Instamart. Yet there are other companies which are also there into market. They are trying to uh, be more competitive in times to come. If you talk about Blinkit, it is so called as Grofers. Earlier, they were working with NCR region, but when they realized that they can be, mitigating the time factor, which has become very important for the individual user, for the individual need. This is the reason companies so called Grofer converted later on into Blinkit, and they are now spread it in more or less not only into metro cities, but they're also now working into non-metro cities, right? So the data says that India's on-demand delivery sector accounted for over two-thirds of all 2024 e-groceries order, with its market share rising to USD 6 to 7 billion from 2022. To differentiate in this highly competitive space, firms increasingly leveraging the AI to deliver the personalized experience, followed by the recommendations. They are also being provided the opportunities of bespokes, and obviously the dynamic user interface and user experience adjustments. Apart from it, there are also possibilities which we can see through these, uh, different we can the companies are in better state of condition to design their predictive restocking conditions, and with the help of the chatbots, they can provide that personalized experiences. If you talk about the problem statement, yes, there are a lot many there are a lot many things which are going on into background. Apart from it, if you talk about the investments, if you look up the problem that I have came across, or we can say the consumers can be the study that has identified is all about, okay, many on demand delivery firms invest in personalization today through recommendations, chatbots, and predictive analytics. But then there is limited empirical studies which have been conducted till now. And apart from it, by and large, how much in form of investment which has been done till date in these kind of AI technology and all, they have been able to translate into loyalty, because ultimately it's not just all about for the consumer who's supposed to uh, repeatedly deciding to buy the product, but it's all about the loyalty, which can be a matter of concern for all these e-commerce companies for in the long run. So ultimately, apart from all these technical aspects, the technical era, the loyalty is one thing which need to be taken care of, and industries need to work a lot, not only to retain the customers, but they also need to uh, look forward about the loyalty that the consumers could be maintaining with them. Then the second most problem statement is what mechanism, like if you talk about the trust, the satisfaction, how much they have been good enough. in providing that personalized influences, uh, providing the personalized uh, influences which will be sufficient enough to leverage that intent of loyalty. Are there any contextual or individual factors apart from this? Maybe the privacy concern, the frequency of the users, the kind of the product they are using, what kind of relationship do we observing? Are they mediating or they are moderating? Then again, does the intensity or the type of personalization matter or not? So based upon this statement, the objectives have been, the research objectives have been decided. The foremost objective is all about to examine the effect of AI powered personalized experiences on consumer loyalty towards on demand delivery platforms in Uttarakhand. Am I audible, ma'am?
Yes, sir, you're audible.
Okay. The second most objective is all about to analyze the mediating roles of the customer satisfaction, trust, and perceived usefulness in this relationship, to identify moderating factors such as privacy concerns, frequency of the platform usage, product categories that might be influencing the strength of the effect of personalization. Because after all, we also need to check out by and large how uh, how much and to what extent these moderating factors are good enough in terms of providing that personalized experiences, and in terms of uh, in terms of loyalty. Then again, to compare the different types of personalization, like what kind of different options being used, maybe in terms of the offers, predictive offers, or maybe through interactions that is happening through chatbots, how they are impacting upon the loyalty. So moving forward, this is my literature review. The study says that there are key drivers that include uh, smartphone penetration. We have seen in the recent past many years that the usage of the smartphones have increased over the period of time, and this is how we can see that yes, through these kind of electronic gadgets, through these smartphones, the things have become convenient. It has provided a lot of ease to people, right? To get things done within no time, no matter whether it is whether the consumer or the user supposed to order something and get things done within short span of time only. So is it the smartphone penetration, or is it the demand that is inculcating with instant gratification? How can we see that there can be a growth in terms of perishable goods and groceries which are being ordered in online mode? And then obviously we also the study also says that there have been a lot of improvements over the period of time through which this unified interface payment system has started to provide ease to many people through different platforms. And yes, obviously the logistics being managed on the other side. The other study says that in India, on-demand delivery have shown explosive growth. There have been extensive growth, and as of 2024, on-demand delivery platforms contributed substantially to the e-grocery market. Further, AI-powered personalization refers to adapting interface, content marketing, recommendations, pricing, delivery expectations, and support services using AI ML based on user behavior, preferences, historical data, and sometimes real-time input. Again, if we talk about the consumer loyalty, the study says it is all um, staying loyal towards a particular brand with a long term commitment, and that is expressed only when the consumer is deciding to repeatedly buy a particular product. So ultimately it is based upon their preferences. Also, it is based upon more on the positivity, the positive word of mouth that the user keeps spreading all around. Then the study is also backed by the theories of the loyalty between behavioral and attitudinal loyalty. If we talk about the in the study, it is found that yes, trust is repeatedly found to be a major mediating factor which playing role in AI personalization loyalty chain. Satisfaction obviously mediates the effect of personalization on loyalty, because when the user is satisfied, it gives him or her a more personalized experience, and that gives him a reason to be a loyal consumer or customer, either
I'm so
directly.
sorry to interrupt, sir, but I'd request you to conclude your
Yeah,
presentation.
yeah. Just give me a few more minutes, ma'am. I would be definitely doing it. Again, privacy concerns and product type may moderate the effects, because personalization requires the data, and AI has transformed the pace of these kind of industry growth, influencing the behavior of the consumers and their pattern in online groceries. The recent data says that in 2025, the global e-commerce market size had been USD 33.9 trillion. Expected market size seems to be 155.9 trillion. And if you talk about the global quick commerce market, there seems to be a paradigm shift. There seems to be a paradigm shift in terms of the groceries, pharmacies, and the convenience delivery. Major growth drivers, obviously we have already discussed these factors: smartphone penetration, AI driven logistics. Again, if you talk about these are the big name and fames that are existing into market, and they are churning a lot many customers. They are seeking a lot of attention towards them, just by providing that that providing just by providing that cutting edge which the customers or the users looking forward. So we have got Blinkit, Zepto, Swiggy, Amazon, Flipkart, and as of now, Blinkit seems to holding the largest market share in India, followed by Zepto, continued to be in pace of expansion into tier 2 cities. Swiggy again remains one of the India's leading instant delivery platform. We already knowing. Amazon, we already knowing again around 100 Indian cities and investing globally in the same drone delivery, right? So if you talk about the Times of India report says, okay, now these big fortune companies, they are globally delivering things through drone delivery system. Again, followed by Flipkart is in state of expanding more and more in terms of their quick commerce. So this is the conceptual framework which have been drafted through this study. AI powered, how AI powered consumer expectation is more or less influenced by moderating as well as mediating as well as moderating factors. So one side we can see there are perceived usefulness, perceived value. There is a trust factor, that building all these three factors, building the customer satisfaction, further building the loyalty and on demand delivery. So the methodology that has been adopted is it has been the research design that has been conducted through the primary and the secondary study. The structural equation modeling has been used for testing the hypothesis relationship. The population size, the population onto which the study has been done, lying within the region of Uttarakhand, and that too with the urban consumers. The respondents onto which this study has been conducted were around 250, out of which 225 samples were collected. Further, stratified sampling method has been used in the study. These are the some profile of the data that has been collected. And if you talk about the measurement model, the abbreviations has been used as consumer expectations as EXP, perceived value as PV in the same way. These variables have been defined accordingly. I hope on these factors in the literature we have already covered, and as ma'am marked me, so I would like to now proceed ahead. Then followed by the test results, the Cronbach alpha have been applied, and we can see that the data seems to be providing us the reliable results. Followed by the structural equation model test has been conducted, and we can see that yes, the results seems to be supportive. Customer experience has a positive effect on perceived value, followed by perceived value influencing the perceived usefulness. Perceived value significantly also improving the satisfaction part also, followed by the perceived usefulness has a positive and significant impact on customer satisfaction. And we can see that yes, through the values of the beta and t value, yes, customer satisfaction is good enough in providing the positive significance in terms of consumer loyalty. Apart from all this, there are yet certain limitations since we are the study has been conducted in context with the technological perspective. So obviously, the data is everything which is being maintained in today's date in the background. All that user likings and dislikings and personalized experiences, all that raw data is being maintained in the background. So obviously, the secrecy, the security of that data need to be ensured. Obviously, personalization, through personalization, may be inducing the feeling of consistent being monitored in the background. We might be having that feeling, okay, we are being monitored. Then followed by, there are they can be least likely to be empathetic, and it doesn't involving any emotional aspects. These are all based upon algorithm, and this is the reason when we use these kind of platforms, we click on certain products, on certain items, and as and when we do not decide to purchase there and then, it is later on being shown to us, reflected to us, as and when we visit the second or consecutive times. There is high dependence of upon
I'm
technology.
so sorry to interrupt, sir,
Yeah,
but we
ma'am,
have
I'm
gone
just
over
concluding.
15
I'm just
minutes.
concluding within 1 minute. I'm just
Yes,
concluding within one
thank you,
minute.
sir.
Yeah. There is a situation, there is a conditions of skepticism involved into it. When the customers do not comprehend, when they won't be able to understand the intent of the promotion properly and exactly, then obviously there can be a creation of situation of skepticism. Obviously, it is all about a doubt into mind, right? That can be further leading to create the trust issues in mind. Then followed by their obviously engaging such kind of technologies perspective into system, into interface, engages lot of high end costs which the industries need to work out. And obviously, at last, the ethical concern which cannot be avoided. I would like to now conclude from my presentation. On demand market is escalating with the significant demand conditions of the consumers. The model is satisfied as the intent is based upon perceived usefulness and certain other factors. These e-commerce companies are working on optimizing the time factor, logistics, and support services, which can be more consumer centric. The sample, the data onto which the study have been conducted is were only limited to urban areas. The uncovered and untouched area, rural, has not been the part of it. So we can say that yes, we can conclude that yes, the study has been partially conducted over to the rural aspects. Yes, there are certain things which is unavoidable, and which is uncovered, right? Then again, AI driven technologies need to build that trust factor within the mind of the consumers, just to get that personalized experiences. And lastly, I would like to conclude now, the customer frequency and pattern to buy through these applications can build trust in the whole chain system. Thank you for my presentation and giving me an opportunity. Thank you so much. These are all my references, and I would be liking for any kind of query from the panel members. Thank you.
Okay, thank you, Dr. Satyam. My question is that how did you collect and analyze your data related to that your research?
Yeah. So basically, try to approach to the users who are using the smartphones, who are preferring to purchasing things through online platforms like Blinkit, who are the users of the Zepto, Blinkit, or Amazon and all. So I tried to collect the data from these kind of profile of the respondents, and after that, the analysis has been done.
Okay. And how can companies finding to improve the customer retention?
Sorry.
So now how can companies,
Yes.
okay, such as Swiggy or Blinkit or Zomato, to
Right.
finding to improve customer retentions?
Obviously, sir, it's a good question. Thank you for asking. Retention is a big deal. It's not just all about the companies deciding in industries. They since there seems to be a paradigm shift into it, they're trying to approach consumers through different modes, like providing the offers, providing taking the redressing the issues of the customers. These are certain things on which these kind of companies like Blinkit, Zepto, and all, they are working. If you talk about the concern of the Zepto, which I have personally observed and which I interacted with the respondents, I got the chance. So they said ki the services are instant. If they deciding to return any things there and then, the cash repayments or the settlement is done within no time. If you talk about the limitations of these, Amazon, and although they have a big brand, they have a big value in the market, but these companies, they do take time, even after you returning the products. If you don't liking it, no matter, it is returned, obviously, but then it takes a lot of time, maybe from 24 to 48 hours, to get things, to get back to to do the settlement with the customers. So these are small things on which these Blinkit and Zeptos have started to working on it, and in times to come, it is going to be giving a cottage to big brands like Amazon and Flipkarts.
Okay. Thank you.
Yeah.
Thank you, sir. Okay.
Thank you so much for all the panel members for providing me an opportunity to present my topic. Thank you so much.
Thank you so much, sir, for your presentation. Before moving
Shall
forward,
I stop sharing my screen now, ma'am?
yes, sir, yes, absolutely.
All right.
I would like to request everyone to please
Yes.
wait for their turn patiently and stay with us until the end. And
All
please adhere to the time limitations that we have.
all right. Thank you.
We'll be moving forward. Now, I'd like to call upon, Venkam Raju Chakravaram to present his paper on AI-driven financial engineering models for predicting consumer behavior in digital economics.
Yes,
You may
ma'am.
start.
I'm available. Can you give me the sharing rights?
Yes, sir, you can try now.
Okay. I share now. My screen is visible.
Yes, sir.
Okay. Am I
I
audible?
request all participants to present your presentation within time. Okay.
Sure. Thank you. Thank you. My voice is okay, ma'am. Oh,
Yes, sir, you're audible. Absolutely.
okay. Thank you. Good afternoon, everybody. Respected track chair and distinguished delegates and other co-researchers. Good afternoon, everybody, once again. So, my name is Venkam Raju from Jindal Global Business School, and it is my pleasure to present our paper titled AI-driven financial engineering models for predicting consumer behavior in digital economies. This research has been jointly carried out with Dr. Sunita Ratnakaram of the same school. The rapid expansion of digital economies has significantly changed consumer financial behavior in this presentation. I will discuss how artificial intelligence and financial engineering can be integrated to improve the prediction of consumer behavior and support better financial decision making. Actually, I am the financial engineering researcher, and Dr. Sunita is the consumer behavior researcher. We both developed this particular research paper, and digital economy, a new era of consumer behavior. Why predicting consumer behavior matters. So the digital economy has fundamentally transformed the way consumers interact with financial products and services. Mobile banking, digital wallets, online investments, e-commerce platforms, and fintech applications continuously generate large volumes of behavioral and transactional data. Traditional statistical models often struggle to capture these dynamic behavioral patterns. Artificial intelligence provides an opportunity to analyze complex relationships within these datasets and generate more accurate predictions. Consequently, financial institutions can improve customer engagement, personalize services, manage risks more effectively, and support evidence based business decisions. So that's why we have undertaken this research study. And coming to the research problem and current challenges, what we are facing are like this. Although traditional financial models, that is statistical models, have served the industry well for many years, they were primarily designed for relatively stable economic environments. Today's consumers behave differently. Their financial decisions are influenced not only by income and spending, but also by technology adoption, online interactions, digital experiences, and behavioral preferences. All these factors are dynamically changing their behaviors. As a result, conventional prediction models often fail to capture these multidimensional influences. This research therefore investigates whether AI driven financial engineering models can significantly improve the prediction of consumer behavior in digital economies. Our research gap and objectives we have shortlisted as follows. Our literature review identified several important research gaps. First, many previous studies relied primarily on financial variables while overlooking behavioral and technological factors. Second, relatively few studies compared multiple machine learning techniques within an integrated financial engineering framework. Accordingly, our study pursued four objectives: to develop AI driven prediction models, to integrate financial, behavioral, and technological variables, to compare different machine learning algorithms, and evaluate their predictive performances. This is our conceptual framework. This slide illustrates the conceptual framework proposed in our study. Consumer behavior is influenced by multiple interacting factors rather than a single variable. Financial variables such as income, credit utilization, spending patterns provide economic insights. Behavioral variables such as financial literacy, consumer confidence, and risk performance explain decision making processes. Technology related variables capture digital adoption, including online banking, mobile payments, and fintech usage. These three categories are integrated into an AI prediction engine, enabling more comprehensive and accurate prediction of consumer behavior. This is our research methodology in the brief: data pre-processing, feature selection, and that all these steps we have followed in the research methodology. We began with an extensive literature review to identify relevant variables and existing prediction approaches. After collecting and preparing the data set, we performed data cleaning, feature engineering, and variable selection to improve model quality. Three machine learning algorithms, these are artificial neural networks, random forest, and support vector machines, were developed and trained. Their predictive performance was then evaluated using appropriate validation techniques and comparison metrics to identify the most effective prediction model. This is our research methodology model. And coming to the results, our empirical findings clearly demonstrate that AI driven financial engineering models outperform conventional prediction approaches. Among the evaluated algorithms, artificial neural networks achieved the highest predictive capability because of their ability to capture complex nonlinear relationships. Random forest also produced highly reliable results owing to its robustness and resistance to overfitting. Support vector machines performed well, particularly for classification tasks. Overall, integrating financial, behavioral, and technological variables significantly improved prediction accuracy, confirming the value of multidisciplinary AI-based financial modeling. So this is the comparative analysis which we have done various features and traditional models and AI models. This slide compares traditional financial prediction methods with AI-driven approaches. Traditional models generally rely on predefined statistical assumptions and linear relationships. AI models, on the other hand, continuously learn from data and adapt to changing consumer behavior. They demonstrate higher prediction accuracy, greater scalability, improved behavioral understanding, and enhanced capability for real time financial decision making. These findings indicate that AI-driven financial engineering provides substantial advantages for analyzing consumer behavior within rapidly evolving digital economies. Key findings. These are the key findings. AI models outperform conventional approaches. Behavioral variables significantly improve prediction accuracy. Hybrid modeling provides superior performance. So these are the practical implications. The findings of the research have several practical implications. Financial institutions can improve customer segmentation, credit risk assessment, fraud detection, and personalized financial services. Fintech companies can develop more intelligent recommendation systems and digital lending platforms. Policymakers can utilize AI driven analysis to support evidence based financial regulation and promote responsible innovation. Ultimately, integrating AI into financial engineering can improve efficiency while enhancing customer experience and financial inclusion. Coming to the conclusion part of my research work, three major takeaways we are proposing. To conclude, digital economies require more intelligent approaches to understand consumer financial behavior. Our research demonstrates that integrating artificial intelligence with financial engineering significantly enhances prediction performance compared with traditional approaches. The combination of financial, behavioral, and technological variables provides a more comprehensive understanding of consumer decision making. We believe that AI driven financial engineering will play an increasingly important role in shaping future financial services, digital commerce, and intelligent decision support systems. Thank you all. That's it about my research work and presentation. You can please ask now questions. Thank you, one and all. Sir,
Yeah.
can I ask questions now? Any?
Yes, sir. Thank you, sir. Nice
Thank
presentation. So, my question is that uh, is your model is scalable for real-time applications?
Yes, sir. It is we can easily adapt, and now we are even also working with some IT experts and programming experts to develop perfect model, sir.
Okay. And what challenges did you face while implementing the proposed methodology or your research?
So see this dynamically changing that morning same respondent given one answer, and evening also she has given different responses. That
Uh,
is dynamically changing the responses by the candidates
okay.
to whom we
Okay.
apply.
Okay. Thank you, sir.
Thank you.
Thank you so much,
Thank,
sir, for your presentation.
thank you. Thank you, ma'am.
We'll be moving forward now. I'd like to invite Priya Shah to present her paper, Bridging the
Yes,
Green Awareness Gap in Stationary Manufacturing, a three-stage AI framework for personalized sustainable design. You may start with your presentation.
yes, ma'am, sure. Ma'am, is my screen visible to you?
Yes, your screen is visible.
Okay, sure. Just a second. So, my name is Priyasha. I am from Adani University. Today, I'm going to present the work titled "Bridging the Green Awareness Gap in Stationary Manufacturing: A Three-Stage AI Framework for Personalized Suitable Design." So, we'll proceed with the presentation. Just a second. So the environmental impact of stationary manufacturing. So as we all know that rising global paper consumption accelerates, which also leads to deforestation. High carbon emissions and water usage in production generate significant industrial waste from stationary manufacturing. The another factor is consumer green intentions rarely translate into sustainable purchases. So it leads to a question like how can AI help consumers make environmentally responsible purchasing decisions? There is also research data which suggests that worldwide paper and paperboard usage, despite decades of digitalization, was around 420 million tons in 2023, and amount expected to increase to 476 million tons by 2032. So this is where we are discussing consumer business environment awareness triangle. It suggests like consumers who desire sustainable products yet defaults to cheaper conventional options. Whereas, as a business perspective, we look forward cost-driven manufacturing with limited incentives to adopt sustainable practices. Whenever we are thinking about the environment, it's like ongoing deforestation, rising carbon footprint, and mounting industrial pollution. So, our motive is to current recommendation systems rarely integrate environmental intelligence, thus leaving a critical gap between green intentions and sustainable purchasing decisions. So, to overcome that, our research has proposed an AI framework for sustainable design. It is divided into three stages. So, first, we are using SVD, which is singular value decomposition. It helps you to analyze historical purchase data to predict personalized preference scores for the notebook features. Second is random forest. It helps you to find the value of cost and sustainability prediction. It predicts the sustainability score and manufacturing cost as per the material, paper type, cover, and binding inputs. Lastly, by the stage 3, we are having multi-objective ranking, which suggests total rank to deliver personalized sustainable notebook recommendations. So you can see the flowchart over here, which suggests like how each panels are interconnected to each other. Stage 1, learning user preferences with SVD. It has two main motives like historical purchase analysis and personalized preference score prediction. So, historical purchase analysis could be possible with SVD because it can find the patterns in past behavior, which reveals which notebook features like material, size, binding a user needs. Another thing is personalized preference score. It could be utilized by the training SVD model according to the user preference scores for unseen notebook configurations. Nextly, with the random forest, the inputs could help you in building AI engine, like four key product attributes feed into the random forest and several model for intelligent prediction. Then we will have the outputs which will be useful in predictions like sustainability score and manufacturing cost. The model predicts eco impact and cost, enabling balanced sustainability aware notebook recommendations. The last stage, which is multi-objective ranking, could be accomplished by combining all the factors in just one formula, which is the main motive of our research, that is total rank. Here, the alpha suggests how much the user is concerned about the environment. Beta tells you that how much user cares about their budget. Sustainability scores will help you to find how good it is for the planet. And lastly, the cost will help you to find how much total budget it will need. So the key research contributions is personalized AI-driven recommendations, sustainability aware manufacturing integration, hybrid AI framework, Industry 5.0 human-centric alignment, and transparent and explainable decision making. There are few limitations and future scope over here. There are limitations like no current industrial deployment is there, and we all know that only static sustainability scoring models are there. The future aim of our research, sorry, is to real world industrial implementation, blockchain supply chain transparency, supply chain API integration, and regional environmental adaptation. So I would like to conclude it with AI-driven personalization empowers sustainable choices. Sustainable manufacturing is essential for future industry. Human-centric Industry 5.0 integration bridges awareness gap and consumer business environment alignment is critical for impact. So now we should focus on sustainability. It shouldn't be a default part, not an it should be a default part rather than being an afterthought. So thank you for giving me the opportunity. If you have any questions, I would like to address.
Sir, do you have any questions for her?
Just let me about your data set, Priya.
Sir, actually, I haven't like practically implemented it. It's just a conceptual framework which I have discussed till now.
Okay.
Okay, thank you, sir.
Thank you so much for your presentation.
Thank you.
Now we'd move forward, and I'd like to call Kavita Kanwar to present her paper on cyberbullying analysis using the explainable benchmark dataset Cyber Explained. You may start with your presentation.
My presentation is visible, ma'am.
Yes, ma'am, we can see your screen, but it's a blank screen. Now we can see your presentation, yeah.
It's visible, ma'am.
Yes, ma'am, it's visible. You may start.
Good afternoon, respected chairperson, distinguished guests, and fellow researchers. I'm Kavita Kanwar, a research scholar from the Department of Computer Science and Engineering, Pune University, Jaipur. Today, I'm presenting my research work titled Cyberbullying Analysis using the explainable benchmark dataset Cyberbullying analysis using the explainable benchmark dataset Cyber Explained. My paper ID is 1010. This work focus on developing an explainable AI framework for cyberbullying detection that not only classifies harmful content but also explain the reason behind each predictions. This is the content of my presentation. It is divided into six sections. Before starting my presentation, first of all, we know about the what is cyberbullying and how it harmful to the persons. Cyberbullying is a bullying that take place through the digital platform like Facebook, Instagram, Twitter, and other social sites. It involves the repeatedly using online communication to intimate, insult, threat, embarrass to another person. Like example, suppose someone repeatedly post comment like you are useless, nobody likes you, go and die. So spread false humors about the someone on social media. These acts are example of cyberbullying because they intentionally cause emotional and psychological harm. So these are the content of my paper. Cyberbullying has become a serious issue due to the rapidly growth of social media platform. Existing AI-based detection systems are capable of identifying harmful content, but they usually work as a black box model, making their decision difficult to understand. To overcome this problem, I introduced a Cyber Explain, an explainable benchmark dataset that provide not only speech level but also target the group information and human return explanations. This framework combines the NLP techniques with the XGBoost classifier to improve the both detection accuracy and interpretability. This proposed model achieves the higher accuracy, precision, and recall. It demonstrates its effectiveness or transparency of the moderation. About the introduction of the paper, social media platforms such as Twitter, Facebook, and Reddit have transformed communication. However, they have also increased the spread of cyberbullying, hate speech, and offensive language. Traditional machine learning and deep learning model can detect harmful content with good accuracy, but they generally cannot explain why a particular message is classified as a cyberbullying. This lack of transparency reduces user trust and makes AI decision difficult to interpret. Therefore, this work introduces a Cyber Explain, which provide the speech category, target group identification, and human return explanations. We first reviewed existing approach for cyberbullying detection. Earlier study mainly use a traditional machine learning algorithm such as SVM and logistic regression. These models rely on manually engineered feature but had difficulty to understanding sentence contents. Later, deep learning models such as CNN and RNN and LSTM improve the detection accuracy by automatically learning the language pattern. For example, I hate you is offensive, whereas I hate waiting in a traffic is not a offensive sentence. Deep learning model are better at distinguish these difficulties. We also use a BERT explainable AI. Transform models such as BERT further improve the language understanding because they consider the complete context of the sentence. For example, you are killing it is actually a compliment, whereas I will kill you is a threat. However, these models still behave like a black box. Extensible AI techniques such as lime and shape solve this problem by highlighting the words responsible for the prediction. This make AI decision more transparency and worthful. Most of AI models only give a prediction such as cyberbullying or not cyberbullying. They do not explain why they made the decision. Explainable AI model like Lime and Shape are the model of explainable show which word influence the prediction. Like you are a useless idiot, the prediction is it is a cyberbullying. Lime may highlight the word useless and idiot as the main reason for the prediction. This help user trust and AI system. The head explain was one of the first data set to provide the human explanation with the instant of saying hate speech. It is also explained why the sentence is considered niche, like a people of religion should not live here. The label is it is a hate speech. Explanation is target a religion community using the discriminatory language. This is the limitation of data set. Uh, Most existing data sets have the several problems, limited content, automation inconsistency, data bias, poor explainability, etc. Because of this limitation, there is a need of a dataset that provide the accurate labels, target group like the gender, religion, or race, human written explanations for every annotations, explainable AI method like the lime and shape. It support for this purpose. This why the cyber explain was developed to improve the both accuracy and transparency of the cyberbullying detection. This is the methodology of the framework. It divided into 6 steps. First of all, we collect the data from the Twitter, Reddit, and other social media sites by using the APIs. Then the label each post of hate speech, offensive speech, or natural speech, and identify the target group and add the human generated explanations. And then we work the pre-processing on the data, clean the data by using tokenization, lowercase conversion. In tokenization, we in tokenization we split a sentence into the smaller unit called the token. Like I hate you, it divide the word in I hate and you, 3 parts. We use the lemonization. It convert the word into the into their base form. Like running is converted into the run, the better is converted into the good. It represent the actual form of the data. Then then In fourth step, the feature selection extract the important text feature using the TF-IDF. TF-IDF is a deep learning approach. It assign the importance to the word based on its frequency or its appearance. Like a word idiot is get a higher score than the other word like among, between, etc. Then we perform the classification, compare the machine learning model like SGBoost, SVM, logistic regression, and random forest to identify the best performing classifier. We use the four classifier for implementation purpose.
Sorry
Explainability, it
to interrupt, ma'am, but I'd request you to conclude your
okay.
presentation.
Apply line and shape to explain the model prediction and improve the transparency. This is the methodology. These are the results after using the four classifiers. Uh, the logistic regression gives the 89, 87, 86 accuracy, precision, and recall metrics, but the SVM give the 91, 89, and 88 performance. The random forest gives the accuracy 93, precision 90, and the recall value is 91. XGBoost is give the high performance of overall. It gives the 95% accuracy, and the precision is 92, and recall value is 94. These are the results. We also use the PCA with globe embedding to reduce the feature dimension while maintaining the importance of information. Overall, the explainable framework provide the both high accuracy and great transparency compared to the traditional black box model. This is the conclusion of the research paper. In conclusion, this research present a cyber explainable and explainable benchmark data set for cyberbullying detection. The proposed frameworks combine the NLP pre-processing features and XGBoost classification and explainable AI technique to achieve the both accurate and interpretable predictions. Compared with the existing approach, it improved the transparency and user trust. Uh, for the future work, develop the multilingual cyberbullying dataset because we have only the dataset in English language. I will try it is in a multi-language. Include the multi-mode dataset like we work on only the text information. We will try to use images and videos also for it. Improve the annotation quality using the counterfactual explanation and reduce the algorithm bias through the fairness evaluation. Integrate the framework with the real world social media moderate. These are the future work of these. These are the references are using throughout the literature review. Thank you, ma'am.
Thank you so much, ma'am. Sir, do you have any questions for her?
Just tell me, Kavita ma'am, which pre-processing techniques were applied to your text data?
Sorry, sir.
What pre-processing techniques are used to your data set to clean your data?
Yes, sir. We applied several pre-processing technique to clean and sanitize the text data before the feature extraction. These include the lowercase conversation, tokenization, stop word removal, spatial character removal. These are all are the part of the pre-processing of data. Lemmatization and normalization.
Okay, and why did you choose these specific modules, that is XGBoost and random forest, or other alternatives?
Sir, actually these are explainable because other old techniques do not provide the explanation of the sentence. It is offensive sentence or not. It is a genuine sentence or not. That's why, sir, I used this. Because
Okay.
lime and shape are the explainable AI methods. These gives the global explanation. Shape is based on game theory. It gives the how much each feature contribute.
Okay, okay, thank you.
Thank you, sir.
Thank you so much, everyone. Now we'll be moving forward. I would like to call upon Sumati Pawar to present her paper on existing and proposed methods of composition of web services. You may start with your presentation.
Someone else is sharing is showing, madam.
Ma'am, you can try now.
Is my screen is visible? Am I
Yes,
audible?
ma'am. Screen.
Yeah. Okay. Title of my paper is Existing and Proposed Methods for Web Services. Is it visible?
Ma'am, I'm sorry, but like your screen is sharing, but I only see a blank screen.
Now?
No.
No, just scrolling now.
Oh,
Yeah.
yeah, we can see it now.
Okay, Nana.
Yes, ma'am. Absolutely. You can start.
Okay. I'm going to get a slideshow. Okay. Web services is a loosely coupled function that can be invoked from a remote location. Web services need to be called either through SOAP request or through REST APIs. In this research, we have done dynamic composition, which is required many of time for multiple services when it's required to execute it at the runtime by combining the output of a particular service with the input of the required service. The problem statement and objectives. The proposed method performs dynamic composition of operations through matching input parameters with the output of available operations in the service after discovery of those services. The objective is this research processes only web services definition language for identifying and managing changes in the web services, as well as the challenge is the identifying the current the signature of the web services, because web-based composition and integration of web services requires solving of complex mathematical problems. That is the challenge. As a methodology, here we are created the multiple composition methods. I'm going to show the slideshow. Yeah, I'm not getting the slideshow for this. Okay. Here we are creating multiple composition plans. Each composition plans will be either with the 2 methods or 3 methods or 4 or n methods. And then we are going to apply a priori algorithm for these composition methods, which is used to give frequently composable methods. The a priori algorithm is used to find out the frequently composable methods. And then we are getting the probability of composition, how it can be composed. To the user, we are going to show the probability of composition. And then we are getting the user request for a particular composition. Indicates the user can choose a particular method for the particular composition, and then the composable services are executed. Means those web services are called and executed automatically according to the composition plan. The steps followed are the storing basic web services in the repository of complex trigonometric web services, because we are going to compose here trigonometric function. Therefore, we have to store the basic web services which gives trigonometric functions, and then calling these basic web services sequentially or in parallel according to the requirement, and then feeding the output of each sequence to the input of the next required web services, then returning final result of complex trigonometric web services to the user. The detailed steps are given here. Collecting the details of published web services is necessary from the website, because the web services are remote and we need to collect the signature through WSDL file. And then During creation of this repository for trigonometry functions, it's required to find those services which are composable. Next, calling or invoking the basic functions according to the requirement or composition plan. And next, during invoking the web services, it is required to also store quality of service parameters. And next, composition of returned result according to sequence maintained in the repository. And this is an innovative process that requires principles of orchestration. And the composition of trigonometric web services diagram is given here, the block diagram. Here we have to collect WST of published trigonometric web services, and then we have to create a repository of complex trigonometric web services as the composable basic web services. Then we have to create dataset for this repository by extracting required parameters from WST. Then we have to call these web services according to the requirement, and we have to store QoS parameters, as well as we have to extract result of executed web services as SOAP response using document object model, and then the compose according to the repository. Implementation is done with the help of WSDR helper class, and WSDR helper API is used, and that is available in the Java library. And result analysis, the recall, we have got the 94% for 300 meters, and we have got 90% for 200 meters. These are 300 and 200 meters are available in the blue and orange. The blue color, the bar indicates composition performance for 300 meters composition, and orange color indicates composition performance for 200 meters composition. Here it shows the recall, accuracy, score, precision, and F measure. As a conclusion, this saves the time. Instead of repeatedly calling the same web services, the saving of time by using already available results from composed web services, and ensuring availability of required web services is possible because we already called those web services, and ensuring quality of service parameter also possible, as well as developing a repository of composable complex trigonometry web services as a sequence of basic web services for future reference, which are required for future. Next, parallel execution of required web service using software as a service with the help of cloud facility. As a future work, we are going to propose a composition method based on multiple AI techniques and analyze these techniques. These are some of the literature review portions available here. These are some of the references. Thank you. Any questions?
So, do you have any questions?
No, ma'am. No.
Since Sir has no questions, thank you so much for the presentation. We'll be moving forward. Now, I'd like to invite Siddharth Sambyal to present his paper on GIDL, a transformer-based framework for genre identification in low-resource Dogri text. You may start with your presentation.
Yeah. Good afternoon, ma'am. Good afternoon, sir. My screen is visible, ma'am.
Yes, sir, your screen is visible.
So, thank you. So, good afternoon, everyone. I'm Siddharth Sambyal from Department of Computer Science and Information Technology, Central University of Jammu. Today, I'm presenting my research title, GIDL, a transformer-based framework for genre identification in low-resource Docker text. This work has been carried out under the guidance of Dr. Bhavna Arora and Dr. Hernan Kaur. And the primary objective of this research is to develop efficient genre identification framework for the Dogri language using a transformer-based deep learning technique. So this is my table of content, and I will be following this throughout my presentation. So In the introduction, natural language processing is a branch of artificial intelligence that enables computer to understand, process, and generate human languages. Some common NLP tasks include machine translation, speech recognitions, question answering, text classification, sentiment analysis. So our works belongs to the text classification domain, where the goal is to automatically classify the document into the predefined categories. The figure illustrates the standard NLP pipeline beginning with the data collection, pre-processing, feature representation, model training, evaluation, and deployment. So, for example, like Gmail automatically classify the emails into promotional, social, or spam. Similarly, our system classifies the Doggy documents into news, poem, and story. So, what is genre? Genre is essentially a way to categorize and classify the different type of document based on their content and group them based on the feature, purpose, and structure pattern that they share. The text is grouped into the genre by examining several common characteristics. These include the writing style, tone, the time period they come from, and the audience they are meant for. So, genre is often seen as the abstract yet defining the characteristics of the various form of media and documents. In the literary analysis, genre acts as a category or type that help to classify a specific piece of literature into a class like poems, stories, etc. So why Dogri? So Dogri is one of the India's 22 official recognized language and is mainly spoken in the Jammu and Kashmir and surrounding regions. However, despite of its cultural importance, Dogri is considered as a low resource language because of very few digital resources available compared to English or like other languages. So these are the research gap that we have find from the literature review. Like till now, no research work has been done in the field of genre identification in Dogri language. Being a low resource language, there is very limited Dogri corpus available online or offline. Challenge with the compound word and rich verb morphology. Limited focus on the dialect variation. And the Dogri lacks in utilization of transformer-based architecture, machine learning, and deep learning approaches. So coming on to the problem statement, Dogri being a low resource language lacks sufficient annotated dataset. Like existing genre identification method are primarily designed for high resource language, not for Dogri. And the problem addressed in this research is the development of resource efficient genre identification that can accurately classify the Dogri documents into the genres like news, poem, stories. So these are my research objectives to study the various existing techniques for the genre identification in different languages, to develop and implement genre identification framework for Dogri documents, to evaluate the performance of the proposed framework with the traditional machine learning evaluation metric. So this is my proposed methodology. The proposed framework GIDL, genre identification for Dogri language, use the contextualized representation that require the specific genre text pattern through its learning system, which improves the ability to classify the Dogri documents. First of all, we have the raw text corpus that contain the different Dogri documents in the unstructured format. Like it will undergo the text cleaning process where the raw text might contain unwanted punctuation, white space, HTML tag, etc. This system strips this out of the text. Then it will undergo the data labeling where we will provide the category to the each genre. Like then the data splitting will be happen where we split the data into the training and testing. The training data will fed to the IndicBot tokenizer. Like we know that computer don't understand the full word well, especially in the morphology rich Indian languages. The tokenizer break the Dogri sentence into the smaller subwords and converts them into the unique numerical IDs. We called it as tokens. Then it will fed to the data collator. Like all the sentence in the batch need to be of same length. If a sentence has 8 tokens and other has 12, the data collator dynamically adds padding tokens like pads to the shorter sentence so that it will match the perfect for like it will equalize. Now it will fed to the IndicBot embedding layer. The numerical IDs are transferred into the high dimensional vectors. Uh, like it will then go to the model training. It is the core of model training. The embedding vectors fed to the IndicBot neural network layers. The model looks at the context of the word, guesses the genre. If the guess go wrong, it adjusts the internal weight. like how this we will train our models. To test it, we'll fed the testing data into the trained model. The model output predicts the genre. And we will evaluate the performance of our model through the evaluation matrices. So the Dogri corpus has been constructed using the publicly available text sourced from the authority online repositories, including dogri.org, jkboss.nic.in, and Sahitmi Academy, women.in, along with using the optical character recognition to extract text from the Dogri literature. The resulting corpus contains the 100 news articles and the 99 poems and 112 stories. This is my sample record from the dataset. So no prior gender identification model exists for the Dogri language. So we have implemented three classical machine learning models: multinomial name base, logistic regression, and linear sport vector machine. These baseline models are used to benchmark the performance of the proposed GIDL framework. The baseline provides the first reproducible reference point of the Dogri genre classification. They enable objective evaluation of the low resource language setting where no comparable prior work is reliable. So this is my results section. The GIDL framework uses the IndicBERT as its base model, which requires 10 training epochs with the ADMW optimizer. The best model checkpoint has been selected based on the macro F1 score. The training and validation loss curve in figure 5 shows the stable convergence result that no exhibit major overfitting problem. The model achieves better semantic and structural pattern detection in the Dogri text through the contextualized embedding than it's through traditional feature technique. So this is my training analysis. This initially both the training and validation losses decreases rapidly, indicating the effective learning. Around the seventh epoch, the model convergence and performance stabilize. The validation loss closely follows the training loss, indicating that the model generalizes well without significant overfitting. So this is my performance comparison. This table compares the GIDL with the traditional machine learning models. Among all the models, GIDL achieved the highest accuracy, precision, recall, and F1 score. The main reason is that the IndicBERT generates contextual embeddings, unlike TF-IDF, which treats word independently. IndicBERT understands the word meaning based on their surrounding context. So in the future, this work has been extended in three directions. First, expand the Dogri corpus by collecting the more annotated documents from the diverse source. Include additional genres such as essays, biographies, dramas, blogs to improve the model generalization. Extend the proposed framework to other low-source Indian language with a similar linguistic characteristics. So these are my references, and that's all from my side. Thank you.
Thank you so much, Siddharth. Sir, do you have any questions for him?
Siddharth, why you choose Dongri language?
Sir, as I'm from JNK, so I think and I want to contribute something to my state, so that's why I've choose Dogri language. And it is also the low resource language and no prior work has been done in Dogri. So that's why I have chosen the Dogri.
And what about your data set?
Sir, dataset I have created my own, sir. The sum of the dataset is available on the online platform, and some of the book data I have collected from books, and I have performed OCR and formed my dataset, sir.
Thank you.
Thank you, sir.
Thank you so much. Now we'll be moving forward to our next presentation. I would like to invite Muskan to present her paper on legal case similarity prediction combining text, network, and events. You may start with your presentation.
Hello. Trying to share my screen real quick.
Yes, Muskan?
Uh, not able to share. Arshdeep, can you share your screen?
Are you guys able to present?
Yeah, just a minute.
Sure, sure.
Can we present at the end of this session? I'm having some issues trying to present the screen.
So we have one more candidate that would be the
Yeah, yeah.
last candidate. So your turn will come after him.
Okay, sure.
Now then, I would like to invite Rajesh Gudpati to present his paper on an AI-driven neuro-specific extension of USDM for standardizing inclusion and exclusion criteria in Alzheimer's clinical trials. So you may start with your presentation.
Yeah. Can you hear me?
Yes, you're audible, sir.
You can see my screen, right?
Yes, sir, we can see your screen.
Yeah. Yeah. Okay. Yeah. Myself, Rajesh from University. Today, I'm presenting my research title, AI-driven neurospecific extension of USDM for standardizing the inclusion and exclusion criteria in Alzheimer's clinical trials. So basically, as we know, Alzheimer's disease is one of the most challenging disorders we know, and successful, clinical trials heavily depend on identifying the right, patient. However, the eligibility criteria, which are typically written, are very unstructured free text, making them very difficult to interpret, for the investigators or the clinical sites or the healthcare systems. To address this challenge, we propose an AI-driven neurospecific extension of USDM that integrates natural language processing and technical reasoning from health groups and to standardize representation. This framework will improve in interoperability and automate eligibility assessment, which will enhance the quality of Alzheimer's clinical. So let me begin discussing the problem that motivated my research. Proposing our solution, it's important to understand the current challenges in the Alzheimer's clinical trials. One of the biggest challenge is the eligibility criteria are primarily written in very unstructured free text. So these criteria are often various and difficult for both humans and computer systems to interpret consistently. The first challenge is the ambiguous and unstructured eligibility criteria, which can result in different interpretations and inconsistent patient selection. The second challenge is the inconsistent interpretation across the study sites, where different investigators may interpret the same eligibility rules differently. So it affects the consistency and in the clinical trials. So another major issue that we see often is that is the limited, interoperability between the health records and the trial management systems. So also we observed a little inefficient patient recruitment as well. So furthermore, what happens is that high screen failure rate occurs because many patients who initially appear eligible are later excluded due to more detailed screening. So finally, this lacks an automation and intelligent optimization source where eligibility assessments remain very manual and time consuming and prone to human error. So, to address these challenges, our research proposes an AI-driven neuro-specific extension of USDM, which I will explain in the next slide. So after identifying the limitations, we identified key research to develop a standardized AI-driven eligibility framework, where our first objective was to develop a new specific extension of the universal study data model that is given by FDA. And the existing USDM provides a generic framework. It doesn't adequately present any neurology concepts uh, therefore, we support uh, 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 clinical research. The second objective was to transform uh, uh, the ability text into structured, computable representations. And the third objective was to improve the interoperability by integrating control vocabularies as CT or CDISC. And the fourth objective was to enable automated eligibility assessment and identifications. Instead of manually reviewing the patient records, our framework automatically evaluates the patient eligibility using structured and machine readable criteria. So finally, our fifth objective was to improve the patient recruitment efficiency and the overall clinical trial success by reducing any manual effort. So here our goal is not only to standardize the eligibility criteria, but also to make them machine interpretable so that enabling the AI-driven patient recruitment and clinical relation support. So having defined our research objectives, I will now present the overall AI framework that integrates these components into a complete end-to-end solution. Yeah. So this slide represents the overall architecture of proposed AI-driven neo-specific USDM framework. It illustrates how our eligibility criteria was transformed into a standardized, computable, clinical knowledge. So the step one, what we do is that the unstructured clinical eligibility text, we begin with the eligibility criteria extracted from the clinical trial protocols we call, where the document is prepared at the initial start of the clinical trials. So these are typically written as free text and may contain information such as, scores, thresholds, neuroimaging findings, and any other clinical conditions. So this information is very unstructured that cannot be directly processed by a healthcare information systems. So our AI extraction, step two is where our AI extraction and normalization engine, where it is powered by the BioBert transformer model that we have used, specifically trained on a biomedical literature. So BioBot performs, very named entity recognition. It automatically identifies the clinically relevant entities such as cognitive scores or biomarkers or any other findings. So these extracted entities are then standardized using the clinical terminologies such as SNOMED CT, CDISC, and other controlled vocabularies that are defined. So finally, the rule-based reasoning and probabilistic inference are applied to improve, the accuracy and reduce the ambiguity here. And in step three, the neuro-specific USDM extension, uh, the standardized entities are then mapped into our proposed neuro-specific USDM extension. So unlike our traditional USDM, this extension introduces a neurological concepts, specific, including you can consider the biomarkers, genetics, very neuro-specific. So this enables the Alzheimer's specific clinical knowledge to be represented in a structured and machine interpretable format. And step four, the knowledge graph and decision support. This structured data is then integrated into a knowledge graph, which captures the relationship between the clinical entities and the eligibility rules. So this representation supports advanced reasoning and also enables the decision support for automated understanding of the eligibility assessment and the patient matching as well. So finally, the framework produces several practical outputs. These include standardizing the eligibility criteria, automating the eligibility assessment, and these outputs will significantly reduce the manual effort while improving the recruitment efficiency. So overall, this framework transforms a free text eligibility criteria into a standardized, computable, and clinical knowledge using AI, enabling the automated patient recruitment and the clinical decision support. So now we have discussed the overall framework. We will talk about. Let me explain you about the methodology used that was to follow to validate this proposed approach. So this slide presents the methodology to validate our AI-driven approach. So we started by collecting Alzheimer's
I'm so sorry to
data from
interrupt, sir, but
NCC, which is yeah,
I'm so sorry to interrupt,
change.
but I'd request you to conclude your presentation in a minute.
Sure. So this is a methodology that we have proposed, and this is the data sets and the participants that we have used in understanding the inclusion and exclusion criteria. So basically how enabling us to train and validate the data. So also we have used the specific extension where you have all the details of how it can be published. This extends the standard USDM by incorporating the Alzheimer's specific clinical trial concept. And this is the mathematical model that we have been used where we have the document representation, the information extraction, and then we have used the entity normalization here. And why this is important is because this provides a formal uh, computable representation of the eligibility criteria instead of relying on manual interpretation of free text. And the results, these are the results that we have produced, where overall what we can say is that these findings confirm that integrating the BioBert transform model and the neurospecific USDM extension improves the extraction of Alzheimer's related information trials. With these results, we demonstrate the improvements in the entity extraction and so here we have clearly demonstrated that there is a reduced screening failures by 37% and increased recruitment by 41%. That shortened the patient identification time by 45%. So that's clearly outperforming the manual and rule-based approaches. So these are the research contributions that have done through my research. That's where we introduces the intelligent framework that transfers free text and eligibility criteria into standardized computable clinical knowledge for automated patient recruitment. So future work, there is a scope for expansion this into other diseases like this is currently Alzheimer's. We might want to expand into improving, federating very learning and transparency to explainable AI, rather enabling continuous model improvement. So I would conclude by saying that this research, we propose this framework by integrating the BioBot model. Our, experimental evaluation show that this proposed will be slightly higher accuracy, and our AI-driven free text eligibility criteria into standardized and computable knowledge will enable smarter patient recruitment, improve interoperability, and more efficient clinical trials. So as I said, like intelligence standardization today will lead to better things. Yeah, thank you for attention. I sincerely appreciate your time and will be happy to answer any questions or discuss the research further. Any other questions we have? Sorry, hope I'm on time.
Sir, do you have any questions for them?
Yes, nice presentation. So let me know what type of clinic data was used to for training and validity your model.
Sorry, sir, what type of? I didn't get your question.
What type of clinical data was used to train
Clinical
and
data.
validate your model? Yeah.
Okay, was used in this model.
Yes.
Is
Yes.
that your question, sir? So basically here what is the, sir? So here we are standardizing the protocol, clinical trial protocol first. and then synthesizing the data, because our model was developed using the Alzheimer's clinical trial data that is publicly available in the National Alzheimer's Coordinating Center, which is NACC. We used both patient level clinical data and the eligibility criteria data from the clinical trial protocols, which is more like the Bible for any clinical trial to start with. So we used cognitive assessments, biomarkers, demographic data, clinical trial, or any cardiovascular disease data, diabetes, depression. All the kinds of data was used in this processing, sir.
Okay, thank you.
Thank you all for your time, and thank you, Pranjal, for giving me the opportunity. Thanks.
Thank you so much for your presentation. Now we'll be moving forward to the last presenter. I would like to invite Muskan to present her paper on legal case similarity prediction, combining text, network, and events. Are you ready to present, Muskan?
Yeah. Hope my screen is visible.
Yes, we can see your screen.
Hello, everyone. Keeping in mind the lack of time that we have today, we'll be presenting our paper, which is titled Case Similarity for Legal Research, Combining Text, Network, and Event. Quickly discussing the agenda for today. I'll firstly explain the problem that we're trying to solve, and I'll also discuss previous research, our data and methodology, and the features we extracted, along with the results, and finally the conclusions and the future work that might be possible. Moving on to the introduction of the problem statement that we're working on. In countries like India, courts often rely on previous judgments while deciding new cases. This is called legal precedent. Today, lawyers mostly search for similar cases using keyword-based search engines like Indian Qanun. However, keywords alone are not enough, oftenly. For example, two cases may contain words like vehicle, driver, road, but one case could be about a road accident while another is about vehicle theft. Even though the words are similar, the legal situations are completely different. So our system doesn't only look at the text, it also checks what actually happened in the case and which laws and previous cases were cited. This is why our solution combines three types of information: semantic meaning of the text, citation network, along with event information. This gives a much better understanding of legal similarity. Let's quickly cover the literature review. Before designing our model, we studied existing approaches, and we found that the earliest methods like the TF-IDF mainly counted matching words, but they could not understand context. Later approaches such as PC rank and higher SPCnet included citation information, which improved retrieval but still had limited semantic understanding. Then in legal BERT was introduced. It was just a BERT model specifically trained on Indian legal documents, so it understands legal language much better. Another important work was the EMB framework, which focused on understanding events inside documents. After reviewing all these methods, we noticed one major gap. No existing approach combines text meaning, citations, and factual events together. This motivated us to study more and build a more hybrid system that uses all three of these. Talking about the data set that we used for training and evaluation, we used the Supreme Court of India judgments. The dataset contains complete judgments, citation information, and expert assigned similarity scores between pairs of cases. However, there were several challenges also. The first one being that legal judgments were very extremely long, sometimes hundreds of pages, while transformer models like BERT can only process about 512 tokens at a time. The second challenge that we faced was that legal documentations contain a lot of complex terminology, and finally, having a similar words does not mean two cases are legally similar. So our model needed to understand both the meaning and the factual context of the case. Finally, moving on to the methodology, our system pipeline. The pipeline has 5 main steps. First, we clean and pre-process the legal documents. Since the documents are very long, we divide them into overlapping chunks using the sliding window approach. Each chunk is processed by in legal board, and then all chunk representations are combined into one document embedding. The next step is to extract 2 additional features. One is citation similarity, and the second is event similarity. Finally, we combine all these similarity scores using weighted averages. And our final scores give 50% weight to semantic text, 30% to factual events, and 20% to citations. The rest of the presentation will be done by Arshdeep, who is a co-author on the same paper. Hello. Arshdeep, are you there?
Yeah. Hello, everybody. Is my voice audible?
Yes.
Okay. So we have a three-dimensional feature extraction. Firstly, we are using the semantic text, which we are giving 50% weightage, which we are using the in-legal bird, which is pre-trained on Indian legal cases, so it understands it better. But due to the long texts of the cases, we are using a sliding window chunking, which we are using a 510 tokens at a time, and then we are taking its mean pooled average to get the final answer. Then for our next feature, we have factual events. So for that, we are using the Spacey library and we are extracting the subject, verb, object triples. For example, it captures the core actions like the uh, subject, which is and what is happening, and then the object of the case. Then we are using lemmatization and we are using Jacquard similarity. And then we have citation networks. For example, if two cases are citing the same previous cases, then the chances of them being also similar are higher. Hence, we are also using citation network and we are giving it 20% weightage. Okay, so next we have our results. Muskan, can you change the slide? Okay. So we have the results. For choosing what is the optimal weight, we have chosen different uh, configurations of our three features. And we have chosen the 50, 30, 20 configuration on the basis of F1 score and accuracy, as we can also see from this table. Okay, so next, Muskan. Okay, so we have our baseline models such as PC rank, MV, and higher SPC and reticle. Am I audible, sir?
Yes, yes,
Okay.
you're
So we are seeing that our proposed models outperforms these baseline models on accuracy, precision, recall, and F1 score. Can we go to the next slide? Okay, so why do our hybrid approach works? Firstly, we are using semantic depth. So fine-tuned in legal BERT will perform better on Indian legal cases. And we are also using factual grounding so that we can see the differences between similar keywords, such as if drug trafficking versus drug injury should be distinguishable. Then we are also using statutory validation using the citation overlaps that we talked about. And most importantly, our model is explainable, more explainable than the illegal BERT because BERT alone acts like a black box. And since we are using 50% of weightage to citations and subject, verb, object triples, hence our recommendations are more explainable than the cases in which we are only using the BERT. Can we go to the next slide? Okay, so for the conclusion, our weighted integration of illegal bird, SVO parsing, and statutory citation are outperforming all of our baselines. And we have found that the optimal configuration is 50% for semantic, 30% for factual, and 20% for citations. And our system bridges the gap between semantic understanding, and we are also have more explainability. So that's all for our presentation. If you have any questions, we would love to take them.
So do you have any questions for him? For her? Sorry.
No questions. Thank you.
Okay then. Thank you so much for your presentation.
Okay, thank you.
Yes.
Thank you.
This was the last presentation of this session. Now, I would sincerely like to thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough, and on behalf of the whole team, thank you for the support during this 11th version and all the 10 previous versions of the conference. We'll be happy to have you in the 12th version in 2027. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD 2026. I would also like to thank our session chair, Dr. Bhagwan Dinkar Thorat, for chairing this session. And now, as a token of appreciation, so this is from our team on behalf of ICT4SD 2026 and Global Knowledge Distribution and partners.
Thank
I would like
thank
to
you,
invite
ma'am.
you to kindly deliver a few closing remarks.
Thank you, ma'am. Their all presentations are very nice. Your coordination is also very nice. Thank you so much, ma'am.
Yes.
It's a really nice organization. Thank you so much.
Thank you so much, sir. I would like to thank all of you here for your valuable presence. Now, I'd request everyone to switch on their cameras so I can take a quick snapshot of this virtual conference. I request everyone to please turn on the cameras. Okay then. Please smile. Thank you so much, everyone. Stay safe, stay healthy. Thank you so much. You may leave the meeting now.
Thank you, ma'am. Thank you.
Thank you.